Hi, this is Mama Maths.
Question 14 from part 2 of the qualifying stage. Let a sub n be a sequence defined by a sub 1 is equal to 17 and a sub n plus 1 equal to 2023 a sub n all over the quantity 2023 minus 2a sub n, and how many terms in the sequence are integers. Okay, the first thing that we want to do is to find an equation where there is n only, not in terms of a sub n. So let's say, so we can, if we want to divide the a sub n, let's say 1 over b sub n is equal to a sub n. So we can write this as 1 over b sub n plus 1 equal to 2023 1 over b sub n over 2023 minus 2 1 over b sub n. Or we can write this as 2023 b sub n minus 2 over 2023, which can be simplified as b sub n minus 2 over 2023. Now, if you want to write this in a form with just n, the nth term of an arithmetic, so this means that this is your d, or your common difference, and your b sub n. So we know a sub 1 is equal to 17, so your b sub 1 will now be 1 over 17. So we can write b sub n is equal to the first term minus 2 over 2023 times n minus 1. Now, if you want to go back to a sub n, this is equivalent to find the common factor. That's 23 and 17. So 2023 times 17. Your denominator will now be 2023 minus 17 times 2, that's 34, and minus 1. Now, for this terms to be an integer, we want it to be a factor, or the denominator should be a factor of 2023 and 17. Now, how many factors do we have for 2023 and 17? We can write this in the form, this is 7 times 17 squared. So we have 7 times 17 cubed. So the number of factors is 2 times 4. So because there's a 7, 1 plus 1, that's 2. 3 plus 1, that's 4. So there are 8. Now, however, there is a restriction here. D is equal to 2023. Let's say D is the denominator. 34 and minus 1. In order for that to be a whole number, or if you want to rearrange it, because we want it to be D, this one. Let's rearrange it. 2023 minus D equal to 34 and minus 1. This should be a multiple of 34. So we will remove the factors that would lead to, or just only 7. So there are 2 factors of that. So there will now have 6 possible for this to have like 34. Okay, why it's 6? Let's say 2023 minus D modulus 34. So D should be equivalent to 2023 mod 34. If we want to divide 2023 by 34, that is, let's say 2023 202 divided 34. How many is that? Approximately 5. 5 times 34, that's 170. What's left here is 32. 3 to 3, so let's say, so that's 9, right? 9. So 9 times 34, so 340 minus 34, that's 306. The remainder is 17. So it should be divisible by 17. So we just remove the 7. So we have like 17, 17 squared, 17 cubed, 17 and 7, 17 squared and 7, 17 and cubed and 7. So there are 6. Okay, I'll list it here. we have 17, 17 squared, 17 cubed, 7 times 17, 7 times 17 squared, 7 times 17 cubed. Okay, now take note. This one is the 2023. This one is greater than 2023. This one is also greater than 2023. Now, since n here should be positive, again, let's rearrange. Let's rearrange this one. If you want to write it as an n, it will become n plus equal to 1 plus 2023 minus d over 34. So, if it's negative, if d is negative, since these are integers, it will give us a positive n. So all 6 will be included. If d is negative, there are 6 numbers. Now, if d is positive, we must not include 7. D must not be equal to 17 cubed and 7 times 17 cubed. So there will now be just 4 numbers. So in total, 6 plus 4, that's equal to 10. Okay, so the answer should be 10. Okay,